Join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Kain, you've been unmuted, and welcome to the server. You're there,
Hey
Kain.
guys. Yep.
Hello, King. How
How
are
are
you?
you?
I'm doing good today.
Good.
What brings you into our server this evening, my friend? Or this afternoon, or this morning, wherever you are?
To be honest, I'm looking to explore new ideas because lately I've grown distrustful of like the media, hearing all these things going around, and I'm wondering if there's anything that I could believe that could maybe be untrue.
Yeah, I can understand that. Especially in times like now, like you pointed out, things seem to be very strange, and it's not uncommon for people to start asking questions and to form a certain amount of distrust. I get it. Not a problem at all. I guess really to say that there should be some kind of distrust is to show that somewhere along the line a lie has been told. So we'd want evidence of that lie, wouldn't we? Conspiracy theories are all well and good. Some of the times we find out they're just conjecture and anecdotal stories, devoid of physical, verifiable evidence. It's interesting today that we are devoid of physical, verified evidence for the claim that the Earth is a spinning ball in a vacuum of space. We are, however, in practical usage and understanding that the Earth to be navigated and to be observed and measured is indeed flat and stationary. And also that we are breathing gas pressure, which requires containment. And if we are told the Earth is declared to be an open system, that means no containment for the gas pressure that needs something to contain it. And a huge problem if we want to keep that gas here, especially if I'm dispersing into said vacuum. So, yeah, it's interesting to ask questions, but it's about the evidence at the end of the day.
Very true. I guess evidence-wise, then, because like this idea of the globe Earth, I don't know. Really, everything I've known, I've been taught or told by someone else or by some outside input. But I don't know. I haven't had anything personally that would lead me to believe that it is globe-shaped. But also, I don't really know anything that would lead me to believe that it's flat. I really can't think of.
It's interesting, and I do completely understand and appreciate what you say, and I do apologise, mate. You're also a little bit quiet, so maybe you could speak closer to your microphone as well. I don't want to interrupt you when you're talking.
I'm sorry.
That's a lot better. Hello, mate.
Thank you.
Yeah, he's better.
Yeah. So it's interesting what you said. You are primarily, and I would agree with you, and I think everybody would, that we are told that the Earth is curving a ball and that it's moving. It's outside of our senses. We experience the Earth not to be moving. We don't experience any movement, for example. The Earth doesn't appear to be moving. We don't see it moving. And ultimately, we don't observe any curvature of the Earth. Those are within our senses. That's what we sense. So I guess the burden of proof will be upon those who suggest otherwise. So again, we're back to the evidence. But I'd agree with you. We understand and we sense the Earth to be flat and stationary.
I think I could agree with that. I guess so. Like, I guess there'd be a couple questions I have that I think you could back with some evidence, which would be, I guess, how would we be able to see like the horizon, for example, like, and where the curvature goes down? How would we be able to see that if it was flat? Because I don't know.
We first have to understand what the horizon is. We were told that the horizon was the kind of the edge or the top of a hill for boats to go over, so eventually if they went far enough we couldn't see them anymore because that hill of water would be in the way. We have to understand that, first of all, that's not what the horizon is. The horizon's optical phenomena. It only exists in your eyes, right? It's the limitation of your view, depending on the optics that you use, so your eyes, binoculars, telescope, or high-powered zoom camera, and then the atmospheric conditions of the day, foggy, clear, whatever. So ultimately, we have to understand what the horizon is. The horizon is the limitation of your view. The Earth is flat, and it's the limitation of your view across that flat surface.
That actually does make a lot of sense. So like, if we were to, oh, I'm sorry.
No, you carry on. You ask your questions, mate, please.
So if we were to have to like determine the size of this like horizontal plane, what would it be then? Because I don't know how far humans can see. I'm just wondering.
Yeah.
Asking questions.
No idea how big the Earth is. Gentleman came in earlier and asked us the size of the Earth and the shape of the Earth. We can only make a claim to the aspect of its surface being flat. How big the Earth is, have no idea. Its overall shape, only God knows, because we would have to be outside of the Earth to see that viewpoint. We're not just talking about outwards, we're also talking about depth, and then we start asking more questions, and maybe questions that we definitely couldn't conceive the answer to. But ultimately, I don't think anybody in this server, any flat earther, 99.9% of the population of the Earth could tell you what the Earth was in its entirety. Most of them think it's a ball.
I understand that. I'm trying to think here of any guess questions I would have to be answered. I guess if you could just give an explanation to me of what your true beliefs are, because I think the flat Earth like concept being portrayed by the media very skewed and apologies, very skewed and I don't know, possibly inflicted, because I don't know, it is to like outsiders, I guess, you know, people like me that are not necessarily in the community and necessarily of the belief right now. It is like a sort of like some sort of hocus pocus. Oh, there's no way this could be real. But honestly, I feel like you do have good evidence to support that. I would just wonder.
It's interesting, again, you say belief. The understanding that the Earth is flat and stationary is because that's what we observe, that's what we measure, and that's what we practically use. For all of those things to take place, the Earth is observed and measured and practically used, as in navigated upon, daily, used with signals which would be interrupted by curved surfaces and military equipment, for example. These things necessitate the Earth to be flat and stationary for them to be used. So what we believe is basically only what we understand. What we understand is the Earth is most definitely not a curved flying ball in a vacuum of space. Why they have lied to us, for example, nobody knows. We could sit here and speculate that all day. That may be one of the larger questions at play, though, as to why they would hide, and I use this word very carefully, creation from us. Don't know. It's interesting you say what we believe, though, is, like I said to the gentleman earlier, and maybe to yourself as well, we all thought the Earth was a spinning ball, the vacuum of space, like everybody was told. We didn't wake up one morning and decide to be flat earthers, and we didn't take inspiration and all knowledge because, for example, the Bible, which is a flat earth book, says that God created that. So from a religious standpoint, we understand the Earth to be flat and stationary for what I said earlier. And anything other than that is up for conjecture, up for speculation, mate. We don't have any other beliefs apart from that.
I apologize for using the word beliefs because I am trying to go into this open-minded. It is sort of a language thing for me, I guess, because like someone that does believe in a globe Earth, their belief is his globe Earth. So I guess what I really need to say, two sides of the situation.
No, that's fine. We speak a lot about belief in this server, and I guess why is because we juxtapose it with the word knowledge and separating those two things. So when people like yourself and primarily, well, everyone, comes into the server and says that they've got a belief, and then we ask them about that belief and they show us that they don't have first-hand knowledge, then we have to understand that it is just a belief and not first-hand knowledge that the Earth is a spinning ball in a vacuum of space. It's something we're told without evidence. The Earth being flat and stationary, though, that is itself evident.
I think that's true. So relative to the Earth, then, what would in the like flat Earth scenario, what would like the position of the sun and the moon and all these other planets be relative to the Earth, would it be different, or are we not able to conceptualize that?
I could only conceptualize it like this. You have a floor and you have a ceiling, and the lights on the ceiling are on the ceiling, and you're on the floor. That's primarily where the sun, moon, and stars appear to be. What medium they reside in, how far away they are, how big they are, and what they actually are, no flat earther, including myself, will be able to tell you. But relatively speaking,
quick.
that up there.
My bad, bro. So yeah, just to Jera's point, you are on the floor, standing on the floor. You can walk across the level plane, right? You are in the medium that is between the roof above your head, the sky above. You're speaking about the sun, so that's above us, right? The things above us. But like Jera is saying, what is the medium up there, and what are they made of? So that's good. Those are good questions. But we know we're standing on the ground, and you probably can agree with that, right? And we're on top of the ground. The things in the sky are above us, and we go across this medium that we're in. Right? Go ahead.
Yeah, that does make sense. I don't know
We are using them for navigation.
I'm sorry, what?
We are using them for navigation.
As like using the stars to find a way. Yes.
Yeah.
I guess I would. In that plane where they are above and the ground is below, that does make a lot of sense, because if you move relative to the globe, I guess the star position would change. But so I don't think. Yeah, it wouldn't really make sense then.
They have same cycle. That means that it's some kind of clock in the sky.
Yeah, I don't know. So I guess the concept of the globe Earth. Would we have any idea where that came from? I guess was my question. I don't know.
Yes and no.
Yeah.
We'll throw a grey area at you. It's some kind of religious idea. We can point back to maybe some Greeks and Plutonic solids if we want to. Or maybe it was a closer idea around the time of the Christian Reformation. Roman Catholicism, for example, and setting up the war between the state and the church, or the church and science, and playing both sides, and giving us the heliocentric model in that way. But it seems to have been drip-fed for us over a period of time, and then over the last 150 years, last 80 years since the invention of NASA, especially in the 1900s, or sorry, the 2000s, last century. Yeah, then. But couldn't really show you who, but a religious idea.
Okay, I see. So it's a bit of a grey area.
Again, it's hard to point fingers directly at this person or that institution, especially when they like to spread themselves out. So I've already spoken about these Greeks and this possibly Egyptian Greek idea and blah blah blah. So yeah, they change names.
It's interesting, but it's connected a lot with religion.
I think a lot of scientific ideas were as well. A lot of things in science are connected to religion. What's known to the masses as like the shape of the Earth, the globe. We have been wrong about many things in the past.
I guess if you want to point at religion, solar and sun worship is kind of evidential, especially in the past, and it seems to be, around today if we look hard enough. Heliocentrism, putting the sun in the center, that's a very religious idea. So it's interesting that maybe these heliocentrists or these sun cults maybe are more responsible. I don't know. Again, it's a grey area for me anyway.
Yeah, but we have that Jesuit priest making Big Bang, like a theory that's coming from the priest. It's not coming from the scientist.
That's a very good point. So in 1929, Roman Catholic Jesuit priest Monsignor Lemaitre came up with the Big Bang Theory. And that's the idea that we know and love today, where everything that we know and love today came from nothing. So nothing exploded, and here we all are, spinning balls in the vacuum of space. That was a Roman Catholic idea. It's interesting to point out that when we talk about a Christian idea that talks about creation, and they talk about nothing creating everything, and especially spinning balls in the vacuum of space, this isn't a Christian idea if you're to read the Bible. The Bible in itself is a flat, stationary earth book, and the earth is in no way a spinning ball. So why would they say that the earth was this and created like that, when really they should be saying that God created everything, right, if they're religious? Didn't.
Mm-hmm. I guess so. I would have a question to ask about gravity, the downward pull of things.
Mm-hmm.
Where would the force be generated from? Because from what I've been taught and told my entire life, it is a globe with mass so big enough that it generates gravitational fields.
Okay.
Would it be the same concept?
Let's rewind the brainwashing, because you have to, because I'm going to say this. Gravity is only applicable to a ball in space. It's not applicable to the flat Earth. Yeah, all right, you might be able to come up with an idea, but that's a mathematical idea. But gravity, no matter which one, mass attracting mass or the bending and warping of space-time, works on the presupposition and only exists on the idea that the Earth is a spinning ball. Because, for example, I'm in the UK and I've got people in Australia, one of them's called Timbo, that are 180 degrees on the other side of the Earth to me, kind of standing upside down and pointing in the wrong direction, whilst the Earth is flying around and spinning. We've also got tidal waters and so on attached, and gas and all that type of shit, which gravity is invoked to do something about. There is no need, I would suggest, for a force, like you said, for gravity, because the Earth isn't pulling everything down. We can only scientifically suggest that whatever the cause is, it has to be something along the lines of relative density, the reason why things go up and down. We can't just only circulate and isolate when we drop a rock. Other things happen in the physical and natural world as well. Things go up. I can place an egg in a container of water, add salt to the water and make the water denser, and the egg will rise. Now, being as this is a quasi, but it is a scientific experiment where I've caused something to happen, in that scientific experiment, the cause of the egg rising when I change the density of the water is density. It's not gravity in any way. No scientific experiment has proven gravity in any way. To prove gravity is the cause of anything, you'd have to have gravity as your independent variable, where you, the scientific researcher, would have to vary and manipulate gravity to see if it causes anything to happen. Today in 2023, we're still subject to two gravitational ideas. One is mass attracting mass, which is superseded over 108 years ago by Einstein's general relativity. Superseded because they couldn't scientifically prove this magic at a distance that Newton didn't want to be associated with. And the Cavendish experiment wasn't a scientific experiment because it didn't follow the scientific method or prove shit. But no, there is no scientific proof of gravity, and whatever the reason things go up and down, we were only limited to relative density. We couldn't give you any other reason why.
Okay. I see.
Thank you for listening. I appreciate it.
Yeah. Yeah, like I said, I am just here to explore maybe a new view on the world, because, you know, I feel as if maybe I can't trust everything that I'm told.
Well, let's maybe
Nowadays.
slow down a little. Let's maybe slow down a little bit here and talk a little bit about gravity and what I said then, because I made the claim that gravity hasn't been scientifically proven, and that we say that because there isn't a scientific experiment, something that follows the scientific method where we manipulate the cause of a phenomena in an experiment that proves gravity. So it's interesting when, I guess, maybe people like yourself come in and ask questions like, why don't you believe in gravity? The short answer is, there isn't a scientific experiment that proves one, sir. So why should we?
Let's see. So I guess the idea would be that the only thing that we can prove is what is in front of us and what we experience, right?
We can prove things in lots of ways. It depends what the question is that you're asking. If you're asking a scientific question like what caused that to happen, then yeah, we can do a scientific experiment to see if it caused that to happen. Other questions like what is that, like the shape of an object, like the Earth, that's not a scientific question, for example. That's an observation and measurement question. But we can know that to be true because we can observe it and measure it. So yeah, we can only really know things in the physical natural world. We can't know things that are supernatural, for example.
I don't really know then. And like anything else I could really ask. Well, obviously there is. I just can't think.
Let me ask you a question. I want to ask you a question. If we wanted to know, like, say, the cause of why an object falls, what experiment could we do to determine what that is?
No experiment, really.
Okay, so that is getting to what Jedi was saying. There is no scientific evidence for gravity because science is based upon experiment, not stories. Right? There's a scientific method, and the scientific method has a particular prescription for how you determine a cause and effect relationship. So the effect is I let go of something, it falls towards the ground. Now I want to know the cause. We know from the scientific method how to determine that. So the cause would be the independent variable, and the effect, the falling, would be the dependent variable. So the way we figure out what causes the effect is we eliminate all other variables, manipulate that independent variable, the presumed cause, and then if there's a change in the effect, then we know that's the cause of the effect, right?
Mm-hmm.
So there's no way to do this with gravity. And in the modern theory of mass attracts mass, right? If I take a car and a bowling ball and throw them off a cliff, right? I change the mass, right? So gravity is supposed to be mass attracting mass. Throw them both up, they fall at the same rate. So now I manipulated the supposed cause and I observed no change, which means that can't be the cause.
We really first have to figure out what gravity is and how we can apply it in any way to science. As in, is it a phenomena or is it the cause of a phenomena? Either way, it has to be physical, and if you're going to suggest it's the cause, then you're going to have to vary and manipulate whatever gravity is. Then you're going to have to start giving us gravity, which is hard because it's not like you can paint it red and put it in a jar, right? When we're talking about science, we most definitely need something in the physical natural world to be happening, because our next question is what caused that to happen. That's all we're interested in science. With gravity, it's kind of hard. Where's the observed phenomena, something happening? And like Injo pointed out, well, you can pick things up all day and drop them. You can be facetious and say, well, you dropped it, therefore you're the cause. But like I pointed out earlier with the egg in the solution of water, if you change that density that the object is in, then something else will happen. The egg, for example, in a denser solution will rise. If you were to drop an anvil onto mercury, it's just going to float there on the top. If you're going to try and take a beach ball down to the bottom of water, you're going to have a really hard time, and when you let it go, it's going to go flying out the top and then come back and rest on the surface. So the world works in a lot of ways. We just seem to isolate. When I drop something, we don't drop everything. For example, when I uncontain gas, that doesn't go down. That goes freely and randomly in all directions, and that's matter. That's gas. So if we're going to say that mass is attracting mass, then mass should be attracting gas, or gas should be attracting gas, and we don't observe those types of phenomena. Especially when we're told that gravity, whichever one we're talking about, is just downwards or inwards to the central radius of a ball, so down from your relative position. But when we realise that everything also means the gas that we're breathing, then not everything goes down.
Mm-hmm.
Sorry, I do apologise. I'll just say this and then I fucking shut up. Sometimes people like to come in here and say that gravity is the cause of why we're breathing, as in why the gas isn't dispersing into the vacuum of space. Because it's an open system, devoid of containment, so something else has to be keeping the gas here. And that will be gravity out of a lot of people's mouths very, very quickly. What I like to remind them is, all right, no problem. I'll give you gravity. You can have it, whichever one. You can say whatever you want about it. I'll give it to you. But scientifically speaking, if we're going to look at gas, it's not doing what gravity says it should be doing. Like I pointed out, just going down. Gas travels freely and randomly in all directions, and I give you gravity, but it isn't touching gas. It isn't decreasing entropy. It isn't stopping gas from dispersing into the vacuum of space, for example.
I see. Guess then I'm just trying to think of anything I could ask to like understand more. I guess is there anything you could tell me that would be like a common misconception? Because like for me, I'm trying to break
Like
out
a
of
common
the
misconception about the globe model. So I'll tell you a whole bunch of them if you want. So
Thank you.
here's one. Do you think that they use the heliocentric model to predict when eclipses happen?
That's a good question, actually.
Because most people think that eclipses are evidence for the heliocentric model, but don't realize that they don't use the heliocentric model to predict when an eclipse happens, because it doesn't work. They use something called the Saros cycle, which has been around since like 2300 BC, predates the globe by thousands of years, and they use it today. It's been used for 5,000 years, this method. They don't use a bunch of modeling spaceballs in a bunch of equations. Eclipses happen at regular intervals, and we know what the intervals are, right? There's actually three particular timings, and when those timings coincide, there's an eclipse at that location.
Let's see. Oh, but that
And
actually.
there's actually cycles within the cycles. There's actually like something like 8 different eclipse cycles. They're just, people figured this out by just watching eclipses over and over again, right? Over time. They didn't have any particular, idea of, they had an idea of the cosmos, of flat Earth cosmology, but they didn't think eclipses were caused by the Earth.
Mm-hmm.
Here's another common misconception. Can you see the moon during a solar eclipse? Do you see the moon block the sun?
No, you just you see like the absence of the moon. You just see black.
Yeah, okay. You're one of the only persons that's ever got that right. There's so many people that swear to God that they saw the moon during the solar eclipse.
Holy shit, I know, right?
Yeah, solar eclipses only happen during a new moon, and you can't see a new moon. So how could anybody see the moon during a solar eclipse if you can't see the moon?
That's true.
Yeah, so these are like common misconceptions that people have, because that's what you asked about, right? This is just like a little teeny example. There's lots of them. So another common misconception is that, since you brought up gravity, that gravity predicts that if you have a bunch of particles, that gravity will form them into a ball. That's actually not correct either. It would only do that in what you would call a special case. So all the particles would have to have equal mass. They would have to be uniformly and evenly distributed in space. And then you'd have to flip gravity on like a switch, and then they would all collapse, equally in the same direction to a ball. But if there's like a asymmetry of matter, like more matter at the top of some like cube versus the bottom, it won't form into a ball. It'll be a different shape, right? So they've run this in simulation. Astronomers, they've tried plenty of times. They can't get their, what people think. They can't get their simulations to form a ball using Newtonian gravity. So
I
often
would.
people come in here like you and
apologies.
say gravity is evidence the Earth is a globe. It's actually not.
I
Because
don't. I didn't say that.
well, I mean, a lot of people, they go, oh, gravity pulls everything to the center. That's like the fourth grade explanation. That's not Newtonian's universal law of gravitation. That law says every particle in the universe attracts every other particle inversely proportional to the square of the distance. It says nothing about a center. Right?
Mhm.
So say you have, twice the amount of particles on one side of the universe than the other. How is that ever going to form a ball? Right? Because when it all comes together and collides, after mass is on one side and then the other side, it's not going to form a ball. So this is just a misconception. We've argued gravity in here thousands of times when it doesn't actually mean anything. Even if they manage to prove that gravity exists as a phenomenon, it doesn't even predict what they want to prove.
Hmm.
Thousands,
would have a
countless
question.
hours wasted. Thousands. I mean, seriously,
a question
it's
about
almost painful to think about.
What was that question about that, mate?
I'm sorry, by the way, for getting off. I would have a question then about the sun and the moon relative to the Earth. So, would you be able to measure the distance of the sun or the moon relative to the Earth? And would that distance change depending on where you are on the Earth?
Yeah. So backwards, depending where you are on the Earth, if the sun is, for example, as we all see it, coming towards you, going overhead, and then going away, then obviously it's changing its distance relative to you. Is it changing its distance relative to the surface? Some people say throughout the year maybe it is. Don't know. I like to point out that be careful when we use the definite article "the sun" because it's making claim to that what we see actually is a physical thing, like the sun being apparent, for example. Even in the heliocentric model, that's the sun 8 minutes ago because of the speed of light. But ultimately, we don't know if that is an actual physical thing we're looking at, primarily because we can't get there and verify what we see is what it is. And ultimately, that goes down to distance as well because we can't get there. We couldn't be able to verify, no matter really what means that we used or whatever mathematics or answer that we got would be not be able to be verifiable to us because we can't get there. So yeah, the sun, moon, and everything else are a little bit out of our reach. Can't actually tell you much about them. We can see them. Can't tell you what they are. Can't tell you how big they are. Can't tell you how far away. Can't tell you how fast they're going. Definitely can't tell you the medium in which they reside. We're kind of really, really limited with that. But yeah, it's kind of difficult to say this is how far the sun away actually is. Lots of people have tried. There are lots of supposed calculations and methods to find it out there, but no one can verify any of them to be true.
They even changed the solar distance about 3 years ago in the heliocentric model. They change it all the time. So, because what can we do, right? All we can do is look at it, right? And maybe hypothetically we could triangulate the distance, but there's no visible parallax. That's how you would actually measure the distance. And even if you did measure that parallax, you'd be making assumptions about the surface you're on in the first place because you're measuring angles, right? So if one position of observation is tilted relative to the orientation of the other, your angle measurements it'll be one thing if it was flat, one thing if it was concave, one thing if it was curved, one thing if you're on a slope, there's always be an assumption. So you could at best claim, well, if I assume that the Earth is a ball and I do this observation, then this. But that doesn't even work because, like I said, there's no parallax. And do you know what I mean by parallax?
I don't think
So
I do.
I can explain it to you very quickly. It's very intuitive, right? It's just a fancy word for something simple. If you stick up your thumb and extend your arm out in front of your face, if you close one eye and open the other and then alternate back and forth, you'll see that your thumb shifts back and forth, right? Depending on what eye you're looking at. That angle change, right? The change in that angle of view, right? And if you know the distance between your pupils, you can calculate how far your thumb is away from your eyes.
Mm-hmm.
Okay? So you can do this with equipment, except for when we do it to the sun, there is no parallax. There's no shift back and forth, no matter how far away we get with the observation points.
So,
And this isn't my claim. This is their claim. This is what they say. So the way they have the current, what they claim is the distance to the sun now, is they didn't know the distance, because you can't get the distance of something just by simply looking at it, right? You can't just like look at a car and go, oh, that car is 10 miles away, right? Especially if there's no other like spatial references, right? So if you see a plane in the sky and you don't know anything about planes, you can't go, well, that's 5 miles, that's 10 miles. It's, you can't do that, right? So we look at all the planets and the stars and everything in the sky. We don't know the actual distances to anything. We can only we only can know like the angular size of it, right? And how much the angle changes through the course of a day or night. So what they did was they said, this guy, using numerology and mysticism, and this is the official story, this isn't flat earth bullshit. He said, Venus is the same size as Earth. And if Venus is the same size as Earth and it has this angular size, I'm going to calculate that it's this distance. Now, we're going to observe Venus cross the face of the sun, and based upon this distance, then its orbit must be this big, and it should take this long for Venus to go across the face of the sun. And if it took this long, then this is how big the sun must be. And if the sun's that big and has an angular size of 0.52 degrees, then it must be this far away. That's how the distance of the sun came about. They didn't get the distance of the sun by actually looking at the sun and measuring where it was. They made a series of assumptions about the Earth, right? So they assumed the Earth's radius, then they assumed Venus has the same radius, then they assumed that the distance to Venus and the orbit, and then the distance to the sun and the speed of the orbit and all that shit. This whole stack, it's called a cosmic distance ladder. They made this stack of assumptions, and they're running around saying the sun is 93 million miles away, and we know, which is it's just a bunch of horse shit.
Mm-hmm.
And this is what people call science. People run around and like, it's scientifically proven. Does that sound like scientifically proven to you?
No, you can't really prove that.
No, it could be correct. Doesn't mean it's wrong, but it's certainly not proven.
It's interesting.
Yeah, I had a guy the other day on a different server in Deal, and he was telling me about how the sunlight comes through his window or something like this, and he set up this whole model. It doesn't work on a flat Earth, and it only works in the heliocentric model, and it's these distances. And I'm like, yeah, okay, how did you get the distances? And he just would not go there, wouldn't go there at all. He weren't biting. I would die for him to say, oh, transit Venus, or even better, radar, or with bounce radar.
Yeah. They bounce off the sun. They bounce the laser off the sun.
Yeah, they got the black body problem, haven't they? Then.
See, they don't understand that. Like, to see the whatever it is, they think they bounce off the sun. They have to look into the sun to see the returning signal, right? Like, how are you going to see a laser beam or even radio waves, because the sun emits radio waves?
Hold on. They've also got.
Go ahead.
They would previously have to know the distance to the sun also, because the Earth isn't going to be in the same place when it shot the laser. It's going to be in a different place. So how the fuck? No, it's all bullshit, man.
Oh yeah,
they needed to know the distance first. Yeah. So they needed to know the distance first.
Yeah, it's a like CB says, it's a claim stacker, right? You just keep stacking claims on top of each other and think like just the weight of a lot of claims equals one proof.
Even if you shoot the laser, what you will do with the surface?
Yeah, I mean, we can just, there's so many problems, we can just go on forever, right? What's it even bouncing off when you said the sun was a gas or a plasma gas,
Yeah,
whatever it is.
exactly.
I love that
Literally
clip
had
for
someone.
McToon where he's like, what does he say? It's just physical enough. I love that. That's so good.
Just physical enough? What is
Oh,
that?
how lucky
We
are
had
we?
someone in here the other day, the same thing, obvious, that was saying this exactly the same thing about we know because we know the distance. I'm like, oh, how do you know the distance? Well, and they said, well, because we know the size. And I'm like, well, how do you know the size? Well, because we know that it was just circular logic.
Yeah, you can't know one without the other. That's always been the problem in astronomy. You can't know the size without the distance, and you can't know the distance without the size. It's like a chicken and egg problem. So how do you get either one of those? By looking at it. You can't. It's not possible.
Without being facetious as well, that's 16 minutes of transit time. If we're talking about, they say that that's the sun 8 minutes ago, so apparent, so because of the speed of light. So if we're sending a laser and then wanting to get it back again, that ping for the laser to return, then that's 18 minutes. 66,000 miles an hour the Earth is said to go around the sun, so I guarantee you we're not in the same fucking place that we were to begin with, right?
Hold on,
But
don't you
yeah,
have to point it to where the sun will be 8 minutes from now or something?
well, look, we're going to start throwing that in as well. Yes. Yeah. You got to know where that's going to be.
Bounce it back to where you're going to be with the rotation and the orbit in 8 minutes.
Yeah, exactly. So you're going to need to know the distance of the sun before you even start thinking about catching light on its way back.
That would be like, how they golfed on the moon? That would be like shooting the golf shot off the moon back to Earth and getting a hole in one.
Yeah, well, we talk about this when they say that they got solar reflectors on the moon, right? And they know the distance to the moon because, they get lasers or photons back. Yeah, there's a bit of a distance to traverse. We're moving, that's moving. That's an interesting shot you've done there. Trick shot of the fucking day, that one.
Trick shot off a curved surface onto a rotating curved surface.
I mean, there's problems everywhere, like Andy pointed out, and it's a big black body problem to begin with.
Well, have you ever played bumper pool?
Andy, sorry.
Well, hold on a second. Do you ever play bumper pool? I know you call it snooker or something, right? But bumper.
Yeah.
It's got the little bumpers in the center, and they're like
they're
round, right? So it is super hard to shoot pool balls off of that shit, dude. No matter how good you are, it's pretty random, kind of not absolutely random, but it's pretty random on how they bounce off. Now imagine trying to do that to something that's 30 miles away and bounce it off of a curved surface and get it to bounce into a direction you want it to bounce at. It's not happening, buddy.
Oh, but maths.
Oh, your math, that's right.
Yeah, I calculated it.
That's why I'm stuck at bumper pool. I didn't have a calculator.
What it is.
It has nothing to do with my motor coordination. It's just my calculator.
Right. Sorry, but Professor Phil's in my DMs and it really pisses me off. Look, Professor Phil, I don't actually read your shit. Don't bother typing, man. I'll tell you what you can. Is he still banned? Or was he ever banned? Because he keeps whining about being banned.
He's banned from my DMs, I know that.
Yeah, he's going to be banned from mine now.
He was given a shot a couple of weeks ago to come in. He had a time limit to come in because he was going off in people's DMs and in the YouTube chat, and he didn't take advantage of it, so he missed out.
Sorry.
Yeah, I remember a little bit about that. Yeah, so you missed the boat, buddy. Smash another satellite into the moon.
So I'm giggling in the background because of what Professor Phil has actually done. He sent me an image of the Earth being a ball with the gas next to the vacuum of space, and he's telling me, look, it's not going away. Basically what he's doing is really weird. I don't understand why he's doing it. He's giving me a picture like something you get from the International Space Station and saying, look, the gas isn't going into the vacuum of space. Proof. What the fuck are you doing?
Picture of Bigfoot riding a unicorn, proving Bigfoot can ride horses. So, Kane, if you got any more questions or whatever, I mean, we could just run around debunking the globe all day. I mean, like,
Yeah.
I don't really have any specific questions to ask anymore. I guess.
I mean, what do you think? What do you think? Like, I'm debating like what question to ask next. There's a whole
Exactly. We've always got a lot to say. It's interesting.
Well,
we want
like,
people to ask questions, don't we?
debunking the globe, right? I also like to support our side, like why
Yeah.
we think the Earth is flat, right?
Triangles.
Yeah,
Navigation.
triangles. There's one.
Probably, it's interesting. It's become my favourite because if you understand it, the Earth can in no way be a ball for the way that we navigate to happen. So, Kane, do you want to understand what I'm talking about a little bit more?
Yeah, of course.
Okay, my friend. So, you've heard of celestial navigation or navigating by the stars, correct? You've heard of that, yeah?
Yes, absolutely.
Do you know how it's done?
Your relative position and your direction, in correlation to the stars.
Yeah, in correlation to the stars, and the way that we find out our correlation to the stars is obviously with compasses, but also with a device called a sextant, which is an angle measuring device. For example, we want to know the elevation of a star above the horizon. Say Polaris is 45 degrees above the horizon. That's kind of the premise of celestial navigation, right?
Mm-hmm.
Okay, so you do know what a triangle is. It's three straight lines that meet at three vertices where the three interior angles can add up to no more than and only 180 degrees. That's right, yeah?
Yes.
Yeah, so we primarily use triangles in celestial navigation. The way that we formulate the triangle is from our position with the sextant to the star, down vertically to a ground position from the star, and then horizontally from the ground position of the star to the observer again with the sextant. So me, star, floor position, me again. That's basically the triangle we're drawing. You understand what I'm saying, yeah?
I guess, yeah, it would. It's a little bit like complicated for me to like understand in a shorter explanation like that. I would really have to look into it, but
Are you in the live stream voice text? The text stream just above.
yeah.
Yeah. Do you see the pictures of triangles that people are drawing? Like one's got a boat, and then there's a 90-degree, and then up there in the sky there's a star or the sun. That's basically what we do with celestial navigation. Quick question: can you you know what a protractor is, right? An angle measuring device, yeah? You find them in stationary sets at school, yeah?
Yeah.
Yeah. Can you measure an angle, so two lines that meet at vertices, if one of those lines is curved? If you've got a curved line, can you measure, for example, 90 degrees?
No, then it wouldn't be 90 degrees anymore.
Of course, absolutely right. You can't measure an angle if one of those lines is curved. A triangle is three straight lines, and you can only measure angles, like I said, if lines are straight. Now, being as we are measuring angles using the surface of the Earth and the ground positions of stars, being as we're using angle measuring devices, we have to understand that if the surface of the Earth was curved, the baseline for every single triangle that we drew would be curved, which would mean problem for two angles. Because if one of those lines is curved, you wouldn't have, for example, a 90-degree ground position underneath that star. And therefore, you most definitely wouldn't be able to read your elevation angle measurement up to that star if that baseline, which would be the Earth, was curved. So understanding that if we're going to be using angle measuring devices, basically just understanding triangles. If we understand that to measure angles, we require lines to be straight, and if the Earth is a curved surface, we are not going to be using angle measuring devices, and we're not going to be using celestial navigation in this way. we wouldn't be able to use a sextant, for example, because the baseline, the Earth, will be curved. Do you understand that?
Yeah.
Yeah.
Because it wouldn't make sense. Because we wouldn't be able to measure it.
Yeah, exactly. So every star in the sky has a ground position on the Earth. It's called its GP. And that angle, straight line down from the star and then horizontal line to you with the sextant, is and always has to be 90 degrees. That's not just one star. That's every single star. Now, being as you can't get 190 degrees on a curved surface, you're not going to get hundreds of thousands on a curved surface now, are you? So understanding that means that the Earth has got to be flat for ground positions of 90 degrees on the surface of the Earth to even exist.
Yeah.
So when we navigate with sextants like we have for over 400 years, and when the power goes off in our airplanes and our boats and captain pulls out a sextant, the Earth is required to be level and in no way be a curved surface. We wouldn't be using angle measurement devices to do so. Therefore, the Earth is flat, navigatably and practically so. Measurably also.
Wow. Yeah, I wouldn't really have any question in that. That's honestly, because mathematically, it wouldn't work with a curved angle. It's not possible.
No, you're correct.
Wow.
See ya.
Welcome
wild.
to Flat Earth. That was very well done, Jetty.
Thank you, Quantum Eraser.
Very well done. And Kain, you took it step by step and evaluated it. It's the first time I ever heard anyone do that. Are you a baller by chance?
I really came here to question my beliefs because from what I've heard recently and what the media portrays, I don't really know what to believe.
Okay.
So I would like to get a different perspective.
Okay, but you went through that. You were calm, measured. I could tell you thought about the words that he said. Kudos to you, sir.
Thank you very much.
To be fair, Quantum Eraser, this young gentleman has been nothing but cordial the whole time he's been here. So it's been a pleasure to talk to him.
Thank you.
I could tell just by his demeanor that he was authentic. So you will not feel the wrath from me. So as soon as I say that, the wrath goes away.
That is scary.
I don't mean to be scary. I'm just saying that I can immediately tell. Just I haven't been in here more than a minute or so, but immediately. I'm sure everyone else in the hangout could tell also.
Thank you very much.
I don't have special powers. Maybe a little bit of intuition than most, but like I said, it's not about me. Outstanding. It gives me hope.
Thank you.
Kain, I gave you like 5 minutes ago his channel. If you saw it on the voice text chat.
Indio, I asked Indio, "Are you here, sir?" He's sitting in the room,
yes.
and then he leaves.
I see that.
Yeah, I posted the link of the person who are speaking now.
You're talking about
playlist.
I'm sorry. Go ahead, Sasha. You talking about?
Yeah, John. Before you came, I posted your link that he looked into.
Oh, so we could look at the. Okay. Thank you.
Yeah, science education. That's right.
Oh, the science part, not the.
Yeah. About all 20s. That there is good part.
Well, there's scientific proofs of the creator. Are you talking about my YouTube channel or website?
YouTube.
Oh, okay. Gotcha.
So, kind of blown away by a triangle there when you came. And understanding that means that the Earth can't be a ball. So, I do appreciate you coming in and asking us, why flat earthers say the things that they do, and being, as you said, that you're starting to question things. This is why we question things, because, like I hope you caught at the beginning, we're kind of evidence based, and this piece of evidence, how we navigate across the face of the earth, requires the earth to be flat. So we say the earth is flat because it's required to be so. It can't be a ball for us to navigate across. So that's why this server exists, and people like myself and Quantum Eraser and Indio and Gemsy and everybody else say the things that we do, because the evidence tells us that the earth is flat and stationary.
Wow.
Got any other questions,
really-
mate?
I don't think I do. To be honest, I was definitely understanding all the things you were saying. But yeah, that one really is the nail in the coffin there. Honestly, that was like no explanation I can think really other than, it would have to be flat, mathematically speaking. There's no like possible way. That's yeah, wow. It's so strange to challenge my beliefs like that, because I'm a very, well, I say, but I'm a very firm person, but I've been trying to change my thought process a little bit, honestly. I really see. Maybe, I don't know. I feel the cogs turning, I guess.
That's, the best place to start. Starting to question, I guess, and I kind of speak for everybody again, what we thought we couldn't question and kind of took for granted. The Earth's a spinning ball in the vacuum of space because everybody tells me so. It's in books, we get taught it at school, and every time I turn on the TV, there it is. So I don't need to question it. The thing is, when you do start questioning it, and I mean actually questioning it, you realise the Earth can't be a ball. It's outside of our senses. The claim is a burden of proof is upon those who make the claim that the Earth is a ball that is spinning. So when we kind of look for that, we don't find that either. We understand that we navigate across the Earth as if it was a flat stationary plane. And we also have to understand that when they give us the primary evidence that the Earth is a ball, because they've been to the vacuum of space and taken pictures / images of a ball, when we realise that that can't even be true in the first instance, as in the place that they're going to, the vacuum of space can't exist, then the entire kind of pack of cards falls apart. There isn't a ball. There never has been a ball. And the only place that there really could be suggested to be a ball can't exist in the first place. So the evidence suggests that we've been lied to. We don't care about what they mean or why they lie. The evidence is the primary thing. The Earth is flat and stationary. It's not what we've been told.
I don't really have much else to say, honestly. Yeah, it's just, I have to rethink myself a little bit, but...
Yeah, the thoughts are pretty much over. It's a reckoning now, because you're going to have to overcome, not you, they're going to have to overcome triangles. To put it simple, not even celestial navigation, triangles, elevation angles, because that can't exist. A Baltard and elevation angles can't exist like an atheist in information. They're paradoxical. They have to deny the existence thereof, each. It's just that simple. I mean, there's many other proofs, but don't need them.
Mm-hmm.
So I would say hold on to your seat, Dorothy, because Kansas is going bye-bye. So stay open, my brother, Kane. It's not about changing from one belief to another. It's about getting rid of all your beliefs because, as far as this goes, this topic, the Earth itself, beliefs don't have anything to do with it. It's about reality.
No, he's right. It's about knowing. It sounds pedantic, but Sonny's correct. Belief is acceptance without evidence. That's what the word means. Many people don't know it. They use it, flippantly, but belief means acceptance without evidence. But now you know, you have the evidence. Knowledge is much different.
Tags! What is your profession?
See, old friend, I brought more soldiers than you did.